we will start the exercise of chapter number 12, that is sound. Okay, so come to the page number 162. Sorry, 160. 162. You see there, the question is about how does the sound produced by a vibrating object in a medium reach your ear? Okay, it is produced and how it is reaching to your ear, that is the point. So this is known as propagation of the sound. So you see, propagation of the sound, you will do it from the notes. Okay, propagation of the sound I have done. So you see here, propagation of the sound. Where is propagation of sound? I have made one diagram of the ear. You can see there, propagation and travel of the sound, how they are like traveling. It is by the compression and rarefaction. So these three conditions you will write down. Okay, so this way it is producing. Now the next question is page number 163. So explain how the sound is produced by your bulbul. Okay, how the sound is produced, that's production of the sound. Okay, so production of the sound you will do here. So sorry, this way. Okay, normal thing is that just by the vibration of the matter. So like vibration, just back and forth movement. So you can make this one also. In this question you can make this diagram, back and forth movement. Okay, so next question is why are the sound waves, question number 2, 163 page number, why are sound waves known as mechanical waves? Okay, why they are known as mechanical wave? Because they can travel through the material medium. Okay, so I gave you one trick also. M for mechanical, M for matter. Okay, so why they are known as mechanical wave? Because they can travel through any material medium. That's when they are known as mechanical wave. Okay, now the next question is question number 3. Suppose you and your friend are on the moon. Will you be able to hear any sound produced by your friend? Think about it. Sound is mechanical waves. They can travel through the matter only. They cannot travel through means if space is there, sound wave cannot travel. That's why you can't hear the voice in the moon. So the answer is no, they cannot travel through the moon. The next one is page number 166. There, which wave property, page number 166, page number which wave property determines the loudness and pitch? I've given you the table. In table you can see what is loudness and what is pitch. So loudness is amplitude scale, pitch is frequency. So that is from the table. You will see from the table, this table, I give you this table. So in the table you can see the loudness and the pitch. Okay, you can see the pitch and loudness. Okay, pitch and then loudness. So both you will write from this one. Now the next one is guess which sound has higher pitch, and guitar or car sound. See, for this high and low pitch you have to learn that table. High pitch and high amplitude I have given. So if high pitch is there, what kind of a sound will be there? If high amplitude is there, then what kind of a sound is there? See there, if loudness is high, the sound will be weak. Loud amplitude. Okay, now they are talking about the pitch. If there is high pitch, okay, there is high pitch, that is known as sharp sound. Okay, so this is the sound of the female voice. Low means deep sound. So they are talking about, the question is about the car horn and the guitar strings. Okay, so when you hear the car horn, what kind of the sound is there? Is it sharp or deep? It's deep, it is not sharp. And when you hear the guitars strings, they are producing a sharp sound. You can like understand by yourself. If it is a deep sound, it is having low frequency and low pitch. If it is sharp, okay, you will not feel the like deepness. You see the male and female means boy and girl. So boy are having a deep voice. So deep voice means they are having the low pitch, and the girls are having sharp voice. They are having the high pitch. The same thing they have this one. Okay, car horn is louder, so it is having the pitch low. Okay, and they are having high pitch. Who is having high pitch? Guitar. Now the next question is, what are wavelength, frequency, time period and amplitude? For this I have given you the table. So it's better like after every chapter you just made the table in the chemistry, physics or biology, everywhere. If you will learn all the formulas and all the processes by making the table, it will be easy for you. So we will just go through that. Now next one is, how are wavelength and frequency related to its speed? I have given you the formula of speed. Okay, 3 formulas of speed are there. So it is that formula they are asking. So these are 3 formula. So they are asking when they are asking wavelength, frequency and speed. In which formula they are related? In this formula. Wavelength, lambda, frequency and speed. These 3 are related in this one. Okay. Now the next one is question number 3. Calculate the wavelength of sound wave whose frequency is 220 Hz. See, frequency is given 220 Hz. Speed is given 440 meter per second. They are asking wavelength. So you have to apply the formula V is equal to nu lambda. First, see, in any equation you have to write down what is given. See here what is given. Frequency is given. Speed is given. You have to find out wavelength. So what is the formula here? V is equal to nu lambda. So you have to find out wavelength. So wavelength will be there. Just do some mathematical operations. So send frequency here because you have to find out wavelength. So wavelength will be here. Send frequency there. So if it is in multiplication, when it will go to other side of the equal sign, it will come into the division. Okay, mathematical operation it is. So wavelength is equal to V by nu. First, listen. First, just write down the thing given in the question. That is the basic trick of solving any question, any numerical in the physics. Write down it, and then just remember in your mind what kind of formulas were there in this chapter. Then just think which formula you can apply there. Okay, so basically what is the thing, the formula is given, so they will give you 2 things and third thing they will ask. Okay, so see, for velocity you are having 3 formulas. Velocity is equal to distance upon time, velocity is equal to 2d by t, means in eco, and third one V is equal to nu lambda. So in this you can apply your third formula only. So the same thing you will do everywhere, and then what you have to first write down a formula and then think about what they are asking, what the question is asking. They are asking about the wavelength, they are not asking about the V, because V is already given. So just make your own formula. That is the basic step. So make your own formula, wavelength, keep it here, V by nu, and put the value, you will get the answer. Now the next question is, answer question number 4. So the question number 4 is, a person is listening to a tone of 500 Hz. So what is given here? A frequency, then distance is given, so from the source of the sound. What is time interval between successive compression from the source? Okay, see, the person is sitting here and here is some speaker. So from the speaker some music is coming. Okay, the distance between the speaker and the person is 450 meter. So they are asking about what is the difference between the compression, means successive compression means wave. Okay, between 2 compression. Okay, I will show you here. Just think about it. This is 450 meter it is given. Okay, that is the person. So successive compression you can like compare it with the wavelength. Okay, this is crest, this is trough. Okay, so what do you call a wavelength? This you will call it wavelength, no? One compression, one crest and one trough is coming. Okay, then from here again the another crest and trough will start. So if crest and trough is there, same you will, this is about the transverse wave, and compression and rarefaction it is in longitudinal wave. If you are confused, then see about here. See here I have given you the same thing in the notes also. See here, this one. Okay, you see here, compression and rarefaction. Compression is equivalent to crest and rarefaction is equivalent to trough. So they are talking about the difference between two compressions, means from this point to this point they are asking. This is first compression, this is second compression, or crust, CC. So from this to this, what it is known as? It is known as wavelength. Okay, so they are asking basically what is the wavelength. So how you will find out this one they are asking about. So there, see, frequency is given. What is frequency? 500 hertz, and then it is given what? Then it is given the time interval. They are asking about time interval.